Hi, I'm Miss Sarah, and this is At Home Makerspace, where every week I show you how to make fun projects with things you can find at home. In last week's video, I showed you how to make decorative paper snowflakes. This week, we'll be digging into the science of snowflakes, and I'll show you how to make paper snowflakes that are based on the patterns of real snowflakes. We'll also be learning more about how snowflakes get their shapes. Now, you probably know that snowflakes are frozen water, but then again, so is ice, like this ice cube. So what makes ice different from a snowflake? Well, ice forms when liquid water freezes. Snow, on the other hand, forms when water vapor freezes. So what's water vapor? It's what happens when liquid water evaporates and turns into a gas. Basically, it's tiny molecules of water floating around through the air. If you've ever stepped outside on a really humid day, the humidity is caused by water vapor. Now, when water vapor freezes, it forms interesting patterns that make up snowflakes. And to learn a bit more about that, we're going to need to take a closer look at a water molecule. Here is a water molecule, which is the smallest bit of water that can exist. You may have heard people call water H2O. That's because it's made up of 2 hydrogen atoms, that's the H2, and 1 oxygen atom, that's the O. In my picture, you can see the 2 hydrogen atoms are these small gray circles, and the oxygen atom is the large red circle. These 3 atoms come together to form this shape, which looks a little bit like Mickey Mouse. Because of this shape, when you get a lot of water molecules together, they form hexagons, which is a 6-sided shape like this. If you want to learn more about why water molecules form these hexagon shapes, be sure to check out the link in the description. But for now, you just need to know that frozen water will form this hexagon shape. If you've ever seen a picture of a snowflake up close, you may have noticed that it also has a hexagon shape. Now, with this basic hexagon shape, you can get all kinds of snowflake patterns. It all depends on the temperature, the amount of water vapor, and the path the snowflake took while falling to Earth. If it happens to be snowing, you can go outside and observe real snowflakes. I would recommend taking a cookie sheet lined with black paper. And if you can, try putting your cookie sheet in the freezer to get it really, really cold. This will help because your snowflakes won't melt as quickly on a cold cookie sheet. You can then observe them with a magnifying glass. If you don't happen to have snow the day you want to do this project, no worries. You can head online and find pictures of snowflakes. The one you saw earlier was taken by Wilson Bentley, whom some of you may know from the popular picture book, Snowflake Bentley. Bentley's pictures can be found through the Smithsonian Institute archive, which I'll link in the description, as well as some other good websites for finding pictures of up-close snowflakes. And now let's learn a little bit more about the different types of snowflakes and make some of our own. To make your snowflakes, you'll need some paper. I'm using colored paper, but use whatever kind you have at home. Scissors, a pencil, tape, a glue stick, and a ruler. The first shape I wanted to show you is one you might not normally think of when you think of snowflakes. It's a column, which is basically a hexagonal tube that may or may not be hollow inside. To make a column, start by folding one side of your paper to make a very narrow rectangle. You're going to continue folding in this way until you have 7 small rectangles. You'll want your first 6 rectangles to be equal in width, as you can see here. And if you think you may have trouble kind of eyeballing this, I would recommend using a ruler to help mark out your 7 little rectangles. The reason we're making 7 rectangles in order to make a 6-sided hexagon is 2 of our rectangles will overlap in order to close it. So as you can see, my last one is narrower, and that's fine. You just need 6 of yours to be the same size, 4, 5, 6, and your 7th can be a little smaller. Now we're going to fold it up so our small one overlaps, and I'm going to grab some tape and tape down the side here, which will keep my paper in this hexagon shape. Make sure you tape all the way down so that it doesn't come undone. And here is my 6-sided column. The next shape we'll explore is the hexagonal plate, which is made up of layers of thin hexagons. To make a hexagonal plate, I'm going to start by turning my rectangular sheet of paper into a square. To do this, I'm going to fold it into this triangle shape. And if you've ever made a traditional paper snowflake, you've probably done this before. Now I'm going to take my scissors and cut this extra rectangle. Be sure to save the little extra bit you cut off because we're actually going to use that a little bit later on. Okay, and now as you can see, when I open it up, I now have a square. So I'm going to keep it folded in this triangle shape, and I'm now going to fold that triangle into thirds. So I'm going to fold one side and then the other. Once again, I am eyeballing here, and it's not exactly lined up, but I think it'll be okay for this project. If you need to unfold and refold things, that's just fine. And the last thing I'm going to do is take my scissors and cut a straight line kind of across the top here. And when I unfold it, I should now have a hexagon shape. Now, if you have some scraps, these can be helpful to make some extra hexagonal plates to layer on top. So here is one that I cut from another piece of paper, and here's a tiny one I made with that leftover scrap of rectangular paper. Now I'm just going to glue everything down. And here is my completed hexagonal plate snowflake. Our next shape is the stellar plate. Now, like the hexagonal plate, it's made of thin layers, and stellar means star-like because it has 6 arms that make it look a little bit like a star. A stellar plate starts the same way as a hexagonal plate. So go ahead and fold and cut it to this step. Now I'm going to sketch out the shape that I want the star's arms to be. So start by drawing 2 straight lines, and near the top of those lines you're actually going to have them come in at a bit of an angle, like so. And now I'm going to grab my scissors and cut out that shape that I've just drawn. So I'm going to start by cutting some straight lines on either side here. And then I'm just going to cut the little corners off on either side. There we go. And now when I open it up, I will have a stellar plate, which has 6 sides, as you can see here. And if you have any scrap, feel free to make a small hexagon to add to the middle. Now go ahead and glue everything in place. And here is our completed stellar plate snowflake. The next shape is one of my favorites. It's called a capped column, and it's basically a column that has a hexagonal plate and or a stellar plate on the ends. Start by folding and taping your column. I made this one exactly the same way as my first column, but I did make it out of a smaller piece of paper. Now make a hexagonal plate. Again, I made this one the same way, just out of smaller paper. And finally, make a stellar plate. Once again, same process, smaller paper. Now we're going to add our plates, one to the top and one to the bottom of our column. And here is my finished capped column snowflake. Our next shape is probably the most famous snowflake shape. It's the one you think of when someone says snowflake, and it's called a stellar dendrite. Now, stellar, as you remember, means star-like because of the 6 arms, and dendrite means something that branches like a tree. And as you can see with the ends here, these little bits do look like tree branches. Our stellar dendrite starts the same way as our hexagon, except I am going to be folding it in half. There we go, and I'm folding it in half just to make it easier to make it symmetrical. Okay, so next I am going to trace the shape I'll be cutting. And the shape will look something like this. Can you see that? Okay, now grab your scissors and we're going to cut around our pattern. All right, now we can open it up and see what it looks like. And what we should end up with is a snowflake that has 6 identical arms that all have this sort of branching shape to them. And there's our stellar dendrite snowflake. Finally, I wanted to share what's probably the fanciest snowflake shape. It's called the Fernlike stellar dendrite. Okay, so stellar, as you remember, means star-like because of the 6 arms, and dendrite means branching like a tree, as we can see here on the edges. Fernlike refers to these feathery edges that might remind you of the leaves of a fern. Once again, we're going to start with that hexagon shape, but then I'm going to fold it in half like we did for our last snowflake in order to help make things more symmetrical. Now we're going to draw our shape, and in some ways this will be similar to the stellar dendrite, but the edges will have a lot more little branches. The edges should look kind of feathery or like the leaves of a fern. Okay. And once I have drawn my shape, I'm going to grab my scissors and cut it out. When you're all done cutting, it should look something like this. And I'm just going to go ahead and open it up. And once again, we should have 6 identical arms. And these arms will have lots of little feathery fern-like branches at the end. And that's a fern-like stellar dendrite. Now I just showed you how to make 6 common snowflake shapes, but there are even more snowflake shapes out there. So whether you make a snowflake based on one of the shapes I shared with you in my video, or you do a bit of research to make another snowflake shape, make sure to grab your completed snowflakes because we're going to do a little test. So I thought it would be fun to see how different shaped snowflakes fall. Does one shape fall faster than another? To test this out, grab two different shapes. Let's start with a column and a stellar dendrite. Which one do you think will fall fastest? Why do you think that is? Let's find out. So as you saw, our column fell faster than our stellar dendrite. And I think there are two reasons that could explain this. First, our column is made with more paper, meaning it's heavier. But I also think that the shape played a role in how fast they fell. Our column fell straight down, while our stellar dendrite seemed to catch air under its arms, allowing it to float down. Let's watch it one more time. Did you notice how the column seemed to fall straight down while the stellar dendrite seemed to float? What do you think would happen if I tested my stellar dendrite against my hexagonal plate? Which one do you think would fall the fastest? And why do you think that is? Let's find out. Now this one was a little harder to see because my hexagonal plate landed off camera, but it does seem that this one fell faster than the stellar dendrite. Once again, it could be because the hexagonal plate has more paper and was heavier, but I also noticed that these two snowflakes fell a little bit differently. The hexagonal plate seemed to tumble like this, whereas the stellar dendrite seemed to rock back and forth as it fell. Let's check the video again and see if you can spot this too. What do you think? Did the two snowflakes fall differently? Another thing you can try is experimenting with the size of your snowflake. So I could compare this large stellar dendrite with this small one. Which one do you think will fall faster and why? Let's find out. Now that was really close, but I do think our small snowflake actually fell faster than our big snowflake. Now you might be wondering, how could that be? The big snowflake is heavier. Well, I think it's because the big snowflake was able to catch more air as it fell, slowing it down even more than our small snowflake. If you want to test this out with some of your own snowflakes, be sure to try size experiments, shape experiments, or even testing out different materials. Does a snowflake made out of lightweight paper fall differently than a snowflake made out of heavy construction paper? I'm excited to see what experiments you'll try and what your results will be. We hope you enjoyed learning about snowflake science and how to make snowflakes based on real snowflake shapes. If you do make some snowflakes of your own, we'd love to see them, so please take a picture and share them with us at the library. You can do so through our Facebook at www.facebook.com/FHCPL, through our Instagram, our handle is @FHCPL, or you can send us an email. Our email address is makerspace@finleylibrary.org. We hope you've been enjoying our Snowflake series. Be sure to tune in again next week for the last of our Snowflake videos. See you then. Bye.